Hey guys, welcome to the video for the lab exercises for Chapter 8. In this chapter, what we're going to do is we're going to actually use some price data and compute the optimal hedge ratio. So we're essentially going to be regressing changes in cash prices on changes in futures prices, recovering this beta and using that to figure out how many corn futures contracts I need to hedge my DDG spot price exposure. Alright, so what we need to do is first compute the optimal hedge ratio for DDGs and corn futures. And this link here, I have extracted some of the important prices from the ISU ethanol plant model, and I've put it here in a format that will be kind of convenient for us to use. So go ahead and open that up. Alright, let's try that again. Let's open it up, and I'm going to open it up with Excel. And you can see we've got this series of prices for cash ethanol, cash distillers grains, and cash corn. So let's go back and look at the formula again. What we need to do to compute the optimal hedge ratio is to compute changes in the spot price. It is to regress changes in the spot price on changes in the futures price. In the CSV file over here, we've got price levels. We need to create our price changes. So I'm here going to make a column called D cash DDG, so difference or change in cash DDG, D cash corn. Alright, now I need to come down to the second row here, or I guess row 3, because I'm going to create a price difference, and to do that I'm going to want to refer to the price here in row 3 minus the price back in row 2. So I can't do that on the first row. There's nothing to reach back to. So we move down 1 and we're able to do it. Now it also turns out this generally works better if we use log differences in the prices, which is approximately percentage change in prices rather than price levels. So we're just going to go ahead and do that. Log price of DDG minus log price of DDG in the previous time period. And if we press enter, we get basically a percent change here. And I'm going to format that not as a currency. Alright, that's fine. And note if I drag this across, I'm going to get exactly what I want also for the corn price column for a percentage change in corn prices. So once I've done that, I can just double click here and fill the formula down. And I'm going to reformat that too. Alright, so now I've got my changes in DDG and changes in cash. I can just go and run a regression of changes in DDGs on changes in the corn price. So to do that in Excel, we go here to the Data tab, and you should have this analysis section. If it doesn't appear there, you need to go enable it by, if you don't see it, come over here to the File menu, click Options, click Add-ins, Go, and this will probably automatically be Excel Add-ins, click Go, and then check the Analysis Tool Pack. Go ahead and check the Solver add-in. It's the Analysis Tool Pack we're using right now, but we may use the Solver later. So just click OK, and these menus will appear. I've already done it, so I'm going to click Cancel. So if you click Data Analysis, at the top you won't see regression, but if you scroll down a little bit, you can see regression there. I'm going to click OK. And for the Y values, I want to input basically the data in column E. So there we go. And for X, we're regressing on to changes in corn prices. So I'm going to highlight column F. And I'm going to put the output here in the same spreadsheet. You'll click the Output Range Radio button, and I'm just going to drop it somewhere here near the top. If I click OK, it gives me my regression output. Alright, so notice what we have here. I'm going to toggle back to our book. We regressed changes in spot prices on changes in futures prices, and it's this basic, simple linear regression. So the intercept coefficient, beta 0, we estimated to be 0.00135. actually not significant. And the beta is here, 0.8448, which is highly significant. So this coefficient on our x variable, on the changes in cash corn prices, is the b that we're looking for. So the way you interpret that is you say, okay, if DDG prices and corn prices correlated perfectly, then you would hedge DDGs with corn on a 1-for-1 basis. But since they're correlated but not perfectly correlated, you don't want to hedge it 1-for-1. You want to say for every 100 pounds of DDGs, I'm going to hedge 84% of that in corn. So let's do a specific example. In the next video, we'll continue the example with number 2 of the assignment.